good afternoon or evening, depending on where you're joining us from. Thank you for joining us for the webinar, which is a follow-up to a webinar that we hosted earlier this year titled Towards a More Comprehensive Assessment of Honeybee Pollen Substitutes. And you can find a link for that webinar in our chat. My name is Shara Yaddo. I'm the Communications Director for Project APIS-M. And Project APIS-M's mission is to fund research and efforts to improve honeybee health and vitality. Our name comes from Apis mellifera, which I'm sure most of you well know is the scientific name for the honeybee. And Project APIS-M was founded as a grassroots effort by beekeepers and almond growers in 2006. We are very proud to announce that we have reached a landmark this year of having funded over $10 million in practical applied honeybee research and have infused over $3 million into forage projects that increase the diversity, density, and duration of blooming plants on the landscape to support pollinators where they need it the most. If you would like to learn more about Project APIS-M, please visit the link in our chat, which will take you to our annual report, or visit projectapism.org. And of course, all of these important research landmarks and forage projects would not be possible without the support of beekeepers and many individuals, corporate sponsorships, and our partners, including the Healthy Hives initiative that has made today's, the research that we will be learning about today possible. And on that note, I would like to introduce you to Dr. Daniel Schmel, who is not only a beekeeper himself, but also a pollinator researcher at Bayer Crop Science. And Dr. Schmel is going to tell us a little bit more about Healthy Hives.
Sounds good. Thanks, Shara. And good evening, good afternoon, everyone on the call. I'm really hoping that you get a lot out of this talk today. So in 2015, about 24 researchers and beekeepers and other stakeholders from across the country came together to identify the most pressing research needs that would make a difference for beekeepers, looking for those tangible, measurable changes to honeybee colony health. And through that, 4 research themes were identified within those individuals in the room, including boosting operational efficiency, discovering and implementing better genetic lines to resist stress, maintain productivity, also making hives smarter through advanced and in-hive monitoring technology, and then implementing this data-driven best management practices, which is really what Dr. Vanessa Corby Harris will be speaking on, one aspect of research contributing to that theme just in a few moments. And so again, we're really trying to aim for those practical solutions that will make applied practical research that will make a positive impact for you as a beekeeper, if you are a beekeeper on the call. And tonight's research that will be highlighted is a perfect example of the type of researcher-beekeeper partnership that was originally envisioned when this initiative was first launched. Dr. Vanessa Corby Harris is a research physiologist at the USDA Carl Hayden Bee Research Laboratory in Tucson, Arizona, and she specializes in honeybee nutrition. And partnering with her in this research, and we'll share a little bit from his perspective on his role within this partnership, is Blake Shook, who's a commercial beekeeper, owner and operator of Desert Creek Honey in Texas, that's offering honey, both retail and wholesale, as well as other hive products outside of Blue Ridge, Texas. So with no further delay, I'll transition it hand it over to Blake, if you can give some remarks for us tonight.
Yes, thank you so much. And I just want to thank you guys for inviting me. And this has been just a really fascinating study to be a part of. And I appreciate all of you guys letting our commercial operation be a part of it. And the results to me are very personal because it's a question I've always had, how much good is pollen substitute doing in the first place? Are there certain kinds that are better than others? What's the long-term effect of these pollen substitutes? And so, as a commercial beekeeper, I'm spending a tremendous amount of money every single year on these pollen substitutes. And so I was thrilled to see such a practical take on this study that could really impact me as a commercial beekeeper and could impact really beekeepers of any scale. And so I'm always on the edge of my seat to see what new findings we have in this study. And I'm looking forward to tonight. I really can't wait to see some of the new research and new studies, and look forward to answering any questions you guys have. If you have any dumb questions for the beekeeper, let me know, and I can answer those. If you have hard questions, you're gonna have to save those for the smart people on the call. But I'm looking forward to it. Thank you.
Vanessa, the floor is yours.
Great, thanks. I'm going to share my screen. Let's hope that this goes seamlessly. All right. Are we all, can we see the screen? Okay, awesome. All right, well, let me get my timer started. Great. Thanks everyone for attending tonight, and thanks again to Project APISM and to Healthy Hives for funding this research and being so supportive of it. So I'm going to tell you today about a project, the results of a project where we were working with Blake to test the value of these different pollen substitutes. And the pollen substitutes in this case were fed in the fall. And so I'm going to tell you a little bit about that as we go along here. The objective for us was to test the effects of different protein supplements on hive health when those supplements were fed in the fall. Let's see, I want to tell you a little bit about kind of the location and where the hives were and sort of their background. The trial was performed on hives that were in North Dakota, and we have North Dakota pictured up there, actually just south of the Canadian border. And the hives spent at least the fall, or the early part of the fall, in North Dakota. They then were moved to Idaho for cold storage. And then after that, they went to almonds in California to, I think it was a location just outside of Fresno. So the design of our experiment, we tested 6 different diets, and these 6 different diets are listed here. One of those 6 diets was a positive control, and that was what I'm referring to as the global 75% pollen. This was sort of the maximum amount of pollen that we could include in a patty while still having this company make them for us, because we needed a lot of diet for this. And so we basically just maxed out the amount of pollen we could put in there. So that's our positive control. The hives were spread across 2 yards, so yard A and yard B. So 2 different locations. Locations were kind of far from each other, but a couple miles, several miles from each other. And let's see. Oh, the other thing I should tell you here is that we did not have a negative control. This is a question that comes up a lot. So I want to address it here. We did not have a negative control because we didn't want to kill hives. We didn't want to not feed them and end up killing these hives. We know that happens when you don't feed them in the fall in this particular situation. So we're trying to maximize the number of hives that we're going to be making it through cold storage and then again into almonds. So the good thing is that this design allows us to maximize the number of hives in our study that were fed these different treatments. But one thing that this study will not tell you is if overall fall feeding is good, okay? But We know that the lack of feed in the fall in this situation is not good already, and that's why we went with that design. I also have the cost of the different patties listed here. So this is just the list price if you get pre-made patties in a package of, I think it was 40 pounds. And let's see, you're also going to see two numbers at the bottom of each square. And these were the sample sizes. So we had about 400 hives that were spread out against these 2 yards. And let's see if this pointer works. Can you see my, not sure if you can see the arrow?
We sure can.
Great, awesome. So the larger number is what I'm going to refer to as the larger subset. And sorry, the smaller number is the smaller subset. And those were ones that we did a more detailed analysis on. So just keep that in mind as I go through the next few slides. So we followed these hives from when we fed them through cold storage. Well, we didn't measure them out of, while they were in cold storage because they're in cold storage. But after cold storage, we did a measurement. This was prior to almonds. Essentially, those hives left cold storage and they went directly into almonds. And they were dropped in the almond orchards and there were still buds on the trees. So the almonds were not in bloom. But several weeks later, the almonds were blooming. And so that would be the last time point that I'll refer to as the in almonds time point. Okay. This period of feeding was about 4 weeks, and the hives got 1 pound a week during this time. The reason why we decided to go with these time points was because this corresponded to Blake's schedule, essentially. So this was the time between when the honey was pulled and when they were being put on the truck for cold storage. Okay, so this is going to be a bit of a review for those who joined us last time. I do want to go over the most important parts of that part of the study before we move on. So I first asked the question, for this larger subset of, or for this larger set of hives, the 400 hives, what factors influence adult population size? So for example, diet, that was definitely something we were interested in. Whether or not these hives were part of that smaller subset where we did the full evaluation. The reason we included that as in our model is that when you do a full evaluation, you have to open up the hive and do a bunch of stuff. So you're a little harder on those hives than the other ones where you're not doing a full evaluation. And then we included yard as an effect in our model. It was a random effect, but others have also found that the location is important, especially in the context of diet studies. And so we thought that was important to include that in our model. And we analyzed these data using a repeated measures analysis for anybody who's one of those statistics nerds. In this larger set of hives, the 400 hives, we did in fact see that diet influenced bee population. So we used seams of bees as our measurement. Some people might know of this as a California count, but essentially if you go out early enough and it's cool and the hives are still clustered, or sorry, the colony is still clustered. If you crack that top and bottom box, you can look up at the top box, count the seams of bees, look down at the bottom box, count the seams of bees, and that was our population estimate. So that's what I'm showing you here on the y-axis. On the x-axis, we have our different diets. And for each of the diets, you're going to see 4 bars, and those are our 4 time points. So August, September, January, February. We did see that, having to do the full evaluation that on a hive, that actually did affect the seams of bees or the adult population. But importantly, we also saw that diet affected the hive population size. However, this was most evident not after the feeding itself, so not in, say, September, and not really after they came out of cold storage, because at that point their populations are all pretty low. But we did see that there was an effective diet when the hives were in almonds, so not until this last time point. And what we saw was that if you compare the positive control, so the 75% pollen, with each of these other 5 diets, there was a significant decrease in size for hives fed megabee, and there was let's say not significant at 0.05, but definitely a p-value below 0.10 for the global patty. So the global 4% patty seemed to perform the best in our trial in this context. So we also had this smaller subset of hives that we did the full evaluation on. And this is essentially a list of all the things that we did. So this was about 120 hives spread across these 2 yards evenly and among the diets evenly. And so we were able to look very closely at, say, the frames in the field. So we pulled out every frame and we asked how much brood is in those hives, what's the adult coverage. We took varroa mite samples, so we collected that in ethanol, and we were able to calculate the number of mites that were detected for every 100 bees. We took samples of bees from the outer frames to look at nosema in the guts of 25 bees pooled per colony. And then we also looked at their levels of lipid and proteins in their fat bodies. And on the bottom right, you're going to see a picture of what a fat body looks like. That's essentially an abdominal carcass with all the GI tract and reproductive tract and venom glands and all that stuff taken out. And I'm going to be talking about that more later. So the good thing about doing these more detailed evaluations is that these data give us more information than just looking at seams of bees. And we can also use them as covariates in our model where we're asking whether diet affects adult population size, brood, things like that. The unfortunate thing is that it's a smaller subset. So sometimes you lose some statistical power with this smaller subset. So using this group of 120 hives, or roughly 120 hives, we followed these hives through, same 4 time points. We lost some along the way, that happens, but using this set of hive data, we again use this repeated measures analysis to look at whether the adult population and brood population was affected by diet. Because we had more information about these hives, we were also able to include information about mite infestation at these time points and nosema levels. The reason why we use these cutoffs, that's usually the cutoff, the suggested cutoff for treatment. So I'm going to show you the information that we, the results from the brood area measurements. Okay, we also have information for the colony size, but here I'm just going to show you on the y-axis frames of brood. Again, diet is on the x-axis, and we have 4 different time points. So in this smaller data set, diet was not as significant, was not as much of a predictor of things like brood area compared to what we might see in a larger data set. But really the take-home point of this set of data was really the mites, and perhaps this is unsurprising, right? Mites are not good. But what we did see was that if we look at the mite levels in August, and then the mite levels in September and subsequently after that, by September, those hives basically had 0 mites. But in August, they still had some mites. And that mite level in August was actually a significant predictor of things like brood area and colony size, going forward, even into, latter parts of the study. So coming out of cold storage and in almonds. And so this to me was interesting because it suggests that, you really have to get your mites under control pretty early, kind of a long time before they're going to be getting ready for winter. And so this to me was quite interesting. So just to kind of summarize this, this part of the data set, this is stuff that we talked about earlier in my previous seminar. Diet did influence bee population in this larger data set, and it looks like hives fed this global 4% diet had more seams of bees than the positive control, than hives fed the positive control diet in almonds. We also saw that mites negatively affected brood populations. I showed you those data, but they also affected adult populations. And in both cases, the data suggests that you have to control the mites well, before August in order to not have a negative effect on your hives. So let's talk next about fat body nutrients. And so I talked about, I sort of showed this picture before when I was talking about the fat body. But I want to sort of tell you about what the fat body does or at least briefly, and why we studied those nutrients. So the fat body is essentially this kind of amorphous tissue. It's spread throughout the abdomen, but you also find it in the head of honeybees, but it's very prevalent in the abdomen. And it does a lot of things, but in the context of nutrition, one of the most important things it does is it stores nutrients. So it stores anything from lipids to carbohydrates to proteins. And so fat body nutrients essentially are an indication of the colony nutrient status. And this is especially important for brood nest bees because they're the ones that convert the pollen that the hive brings in to colony growth and survival. And this happens because they use the proteins that are stored in their fat body to make brood food. And so if you look at brood nest bees in the spring and summer and you look at their fat bodies, they can be an indication of the ability of that colony to rear brood, or the ability of that colony to gather enough nutrition so that they can then use that for brood food. If you look at hives from the fall, that fat body will actually tell you something slightly different because brood rearing should be going down at that point. And so really what that the fat bodies from that time period are going to tell you is something about how the hive is preparing for winter and their likelihood of making it through winter. So what does a fat body look like at these different time points? So we have, let's see, fat body lipids on the left and fat body proteins on the right. And what I'm showing you here is the positive control data. So these are bees that were fed, the maximum amount of natural pollen that we could give them in a patty form. On the x-axis, you have the different time points where we measured them. And on the y-axis is the micrograms of that particular nutrient per milligram of bee or per dry weight of bee. So let's kind of go through these a little bit. Let's see here. So let's look at the fat body lipids first. And in the fall, during this period of feeding between August and the end of September, fat body lipids rose. In cold storage, they fell. And then as the hives are come out of cold storage and they're in almonds, they start to rise again. So what this tells me is that bees are packing on lipids in the fall. They use that energy that's in the lipids as they're in cold storage. And then when they're coming out And as that hive is starting to send out more foragers, and they're starting to bring in more pollen, and sort of balancing the needs of a hive that are in this growth phase, the lipid levels, it goes up slightly, but not that much. Let's see. In the protein data, we see that hives, the protein levels go down a lot between the pre-feed and the post-feed time points, and again after storage. We do not see that the fat body proteins went up too much at this point when they were in almonds, but I think I'm not 100% sure, but based on what we know from other studies and from our work, we think this is because there was still open brood when those hives were going into cold storage. So essentially, as those bees went into cold storage, and also they had no pollen stores at that point, they had consumed all of their diet, there were no pollen stores, and there was still brood to feed. And so they were essentially using up their body's individual resources to rear brood. And then after that, after brood rearing did stop, some point, in here, we don't know when exactly, but when brood rearing did stop, they essentially just burned through their proteins for energy. That's what I think is happening. The lipid data, interesting thing about the lipid data is this is the same pattern you see whether you're in Tucson, Arizona, or Ontario in Canada, like outside of Toronto. These sort of rising of lipids in the fall, and then the fall, the decline of lipids in the winter, that happens in a lot of different situations, and it's a pretty consistent theme. So, okay, that's great, but what about the different diets? Well, this is what we saw. So we did see that these seasonal patterns, so this is the lipid data, we did see these seasonal patterns of rise and fall between this feeding period and then the fall as they were in storage, okay? Let's see, the averages of those levels and the standard error are up there if you'd like to look at those more closely. We did see that fat body lipids in these hives did change with diet, and it was pretty significant. And let's see, one thing that was really interesting in these data was that there were differences in the rate of loss or gain, okay? And this was most evident in the hives fed the global 4% patty. So these actually showed essentially a 9-fold increase in their levels of fat body lipids. And this was the largest increase that we saw in the fall. And this was actually, this actually really jumped out at us when we were looking over these data. And so we think that this is potentially an important thing for hives as they're moving into this period of winter cold storage, those sort of processes that might actually benefit them coming out in the spring. With regards to fat body proteins, again, we have the same data sort of set up here. This is the protein per milligram of B. We did see these similar as our positive control. We saw similar patterns of decline in all of these, in the hives fed these different diets. Diet did affect the fat body protein levels, but they were all kind of declining parallel to each other. So they were all kind of proportional to each other. And so there were no differences, no significant differences anyway, in their rate of decline, okay? So I think well, here, let me also point out the global 4% patty too, which is this green here. Okay, so they had essentially an average amount of fat body protein. Okay, so nothing remarkable about these, but this could suggest that, in consideration with the fat body lipid data, together, I think this suggests that maybe for bees going into the fall and then that have to survive the winter, maybe this is only the case for cold storage, I don't know. But it seems like prioritizing lipid storage over a huge amount of protein storage might actually be a good thing. And we think this because the global 4% or the hives fed that 4% diet actually did the best in almonds. This has to be rigorously tested. At this point, this is just correlation, I guess. But I think it's very interesting. And so something that we really want to follow up on. So the overall conclusions that we're getting from this, again, much of this I talked about in my earlier seminar, but I just want to reiterate that it's very important that we control the number of mites in our hives by August, potentially even well before August. The other thing is that this global 4% diet was actually the cheapest diet that we tested. And so I think we can say from this that the cost of a diet does not necessarily translate into better colony performance. And so I think that's something to consider when you're thinking about if you want to feed and what you want to feed. Also, the fat body nutrients, the lipid and the protein, they did change across time. The changes were affected by diet. I think the most interesting feature of that data set were the lipids. And so hives fed this global 4% patty, the ones that have the most frames of bees in almonds, they showed the greatest gain of lipids during this fall feeding period. They showed medium amounts of fat body proteins throughout in comparison with the other diets. So that might suggest that we need to think about having diets that help bees to pack on fat essentially in the fall is really important. And so with that, I will thank everyone, and hopefully I didn't go too much over time, and hopefully there's some time for discussion or questions. So thank you all so much.
Thanks, Vanessa. That was great. Yeah, we have plenty of time left for questions. So if anyone has them, please feel free to put them in the chat or to go ahead and raise your hand, which you can find in at the bottom of your screen under the reactions button. And it looks like we do have a couple of questions in here already. I have a question from Anthony Antonucci. Is fat body in an adult bee a finite amount? So as Varroa feed on it, how much is being depleted? And will this limit the amount of lipid protein that will be stored in those bees that are overwintering?
Right. So it's not finite. Well, I guess the entire abdomen can't be completely taken up by fat body, right? They have to have room for other organs, and it does, but it does grow and shrink depending on the time of year, the role that the hives are, that the bees are playing in the colony. So typically brood nest bees have more lipids and proteins in their fat body than say a forager. And so the Varroa, let's see, I just want to make sure I'm seeing this the right way. Yeah, the Varroa, there's definitely some good evidence out there that the Varroa do feed on the fat body. I don't know that we know exactly the quantity that they consume at this point. I would think that that's probably a function of things like mite load. And so I think it's probably in the context of fat body, that's going to be depleted, due to a lot of different things, whether it's poor nutrition, aging, or varroa. So hopefully I kind of addressed that.
Yeah, and a similar question from Dan Schmel. Does varroa parasitization impact lipid or protein levels in the fat body? Do you know that?
I don't. To date, to my knowledge, and I'm sure there's, people looking at this very closely, we have good evidence from sort of microscopy, talking about, where the varroa sort of start feeding and how that relates to the different honeybee tissues, but the amount that they're taking out, I don't know.
Thank you. Yeah, it's an interesting question. This is from Danielle Downey. Both fat and protein levels look like there might be differences in the pre-feed averages. Is this just an artifact?
Right. So yeah, there were differences, but the repeated measures accounts for that when it does the analysis. So it's essentially saying, we know that there's, even though we tried to equalize the hives, there's only so much you can do. And so the repeated measures analysis should take that into account. And it essentially asks, well, given this level that was present, before the feed was even applied, what are there differences even after that has been taken into account? Now, what that could also indicate is that there's other stressors that we didn't measure that might also be affecting the fat body. So say infection, immunity is a very energetically expensive physiological function in a bee. And so although we did not see any evidence of, we tried to pick the healthy hives, it's possible that certain ones had a higher, say, disease burden that turned up in the pre-feed fat body measurements. But the repeated measures should take that into account.
Thank you. We have one from Carol. Did the colonies with mite drops between July or maybe August and September have treatments applied?
Right. So not while we were doing our experiments. So the first time we met those hives was in August, and there was evidence of a mite treatment when we went there. I presume that happened right after the honey was pulled, but I'd have to defer to Blake on that one. But there was a treatment, yes.
Yeah. So the treatment occurred. The treatment concluded about a week before the trial, or maybe even days before the trial started. But yeah, it was concluded right before the pollen patties were applied.
Right.
Were outside pollen sources available during the feed period, or were the bees confined?
So the bees were not confined except when they were in cold storage. So cold storage is a cold storage unit, and they're all, in the hive at that point. They won't come out because it's kept at a very low temperature constantly, or at least a cool temperature constantly, like a refrigerated unit. In the fall, they did have access to pollen. There was a lot of sunflower actually, or things that composite looking types of forage. And whether was a crop or even just, on the side of the road, the wild cultivars of things. And they were bringing in pollen, and actually in August during that first measurement, they did have a decent amount of pollen. But apparently it wasn't enough because, number one, they did eat the diet. In my experience, and of course, other people might have different experiences, bees will always prefer pollen over a diet. They ate all of their diet. So that tells me that the environment was not providing enough. And number two, they didn't have any pollen stores at that second post-feed measurement. So suggesting that either the queen was still laying a lot, and so they were going through that pollen really fast, or they weren't bringing in enough to store. So in cases of, rapid brood rearing, they won't have a whole lot of pollen stores. They'll be going through that pretty quickly. So they were bringing in pollen, but clearly it was not enough for what they needed.
Thank you. I'm going to skip to a question for Blake. And the question is, have you considered making adjustments to your management practices of feeding pollen patties based on these results?
Yes. I mean, we were certainly taking a fresh look at the brand that we use. And I think that, this is one study in one geographical area in 1 year. And so we don't want to just automatically assume that global 4% is the way to go across the nation any time of the year. This study could be expanded a lot to learn more, but it's interesting because that was the product that we were most comfortable using that time of year in that part of the country already. And the study just kind of proved that for us. And so we're certainly sticking with that. But for us, I mean, we're branching out even further, and internally, we are certainly trying other brands and doing a comparison to see if the same results happen for each year. And then we're trying out some negative controls too with no pollen substitute whatsoever, just to see what happens. We really view pollen substitute as an insurance. Some years I think that they probably do fine without it when you have a heavy fall pollen flow. And then some years they don't. And, we aren't willing to risk it and not feed anything because, that could be catastrophic in a year that there isn't sufficient forage for them. So yeah, it certainly made us look at several things and certainly made us explore further.
Right. I think it's important to remember too that year, last year in North Dakota there was a very severe drought. And even when we went there at the end of September, it was still hot outside. Like it was, almost as warm. Well, in August, actually, when we went up before we applied the diet, it was actually as hot in North Dakota as it was in Tucson. So it was a warm year and everyone was complaining about the drought. And actually some of the information out of the National Ag Statistics Center or Service, has shown that there was definitely a decrease in the honey crop due to the drought this past year. So this could have been, I think in some ways maybe we were fortunate perhaps because they did eat all that diet and it was a year when they needed it.
Yeah, those are both really important points to think about. This is from Matt Cox. If lipids and fat seem to be the most beneficial, they are curious if there's been any research that can be done to add lipids and fats to a syrup fed in the fall.
Okay, so it's not going to dissolve in syrup. So you can't really get it into the syrup just because, fats like oil and water, it's not going to dissolve in anything like that. There is definitely variation in the lipid content of different diets that we've tested. We haven't tested all the ones here, but there's definitely differences, and there's also differences in their essential fatty acid content, which is the main component of, the main type of lipid that they get from pollen. So yeah, I think if you wanted to add, find a way of adding lipids, you'd have to put them in sort of like a pollen patty substitute type of situation.
Makes sense. excuse me, this is a data question where the brood areas and hive weight totals considered over the 4 periods.
Yeah, so brood area was, this was just in the smaller subset though, where we did the more sort of complete, intense measurements. We did not look at hive weight. We only looked at adult population size.
And I'm not sure if we have enough information to answer this question yet, but this is from Charles. Can we put a dollar value of the input of a pollen substitute versus payback in frames of bees?
Right, so I think I haven't presented those data, but essentially, you have to look at the increase in population size or the increase in brood area per unit of pollen applied. Well, they all ate all of their diet. So that's essential, and 1 pound, they were all fed the same amount of diet. So that's equal. So essentially the differences are going to be the differences in the cost among those different ones. Now per bee or per seam of bee, I do have that information. I don't have it handy right now, but I'm happy to email that to you, in terms of seams of bees. But it's still going to hold that the least expensive diet is actually going to give you your most growth, I guess, in terms of adult population. So more bang for your buck.
From Medat Nasser in Canada, can you provide the percentage of protein and lipids in the tested diets, or will there eventually be a place people can access that?
Yes, so for some of these, actually, we do have that information in a paper that we published in Apidology a few months ago, I think. As for the patties made by Global, we don't have that information, but I do think that, well, you'd probably know where to find that. But my hunch is because of the fact that 4% or 75% comes from pollen, and pollen has a lot of protein and lipid. Those are going to have, a decent amount of protein and lipid in them too.
Let's see.
But the plan is to, now that we've run all those samples of the fat bodies and everything, that will be additional information that we will provide that we hadn't thought of before, but we will be doing that very soon.
I have one from Carolyn. Hi, Carolyn. Do you want to assess temperature and climate issues in future research? I'm assuming in relation to nutrition.
Yeah, so that's actually something we're doing now in our lab, and not this particular project, but that's definitely a focus of where we're going in the future in the context of nutrition for sure. So for example, there's a lot of folks that have been looking at, bloom times and, how that's affected by things like climate, like drought, temperature, things like that. But one thing that I'm very interested in, and we have some preliminary data to support this idea, is that, and others have found this too, it's just there's not a whole lot of stuff out there yet, is that the nutritional value of the pollen itself is affected by things like that. So say more stressful climates, that the plant might not invest as much nutrition into the pollen. And so that's something that we're looking at in more detail. We're just kind of starting that research though, so have to stay tuned.
This could be for Vanessa or Blake. kind of any suggestions we gleaned from this research for the hobbyist or sideliner beekeepers as how to approach pollen substitute feeding, especially in preparation for a winter?
I don't want to hear what Blake has to say.
Yeah, I mean, I think this is one of those areas for me that it doesn't matter if you're a hobbyist or a commercial beekeeper. I mean, obviously, we're trying to look at the, the value to a commercial beekeeper financially, because we're spending, tens of thousands or hundreds of thousands of dollars a year on pollen substitute. But I think that the importance and really the methodology doesn't change whether you're a hobbyist or a commercial beekeeper. So, I would say the importance of using a good diet is there, and then feeding that pollen substitute leading up to your winter months, whenever that is. And in my operation, what I usually recommend to people of any scale is that, ideally up to a couple months before you start getting your first freezes, you're feeding that pollen substitute to build up those fat bodies in a bee, and so that they're able to more effectively overwinter and come out on the other side. So, I would say do the exact same thing as a hobbyist as we're doing on a commercial level, which is starting a few months out and starting that pollen substitute feeding.
Like, this is Danielle. Sorry, Vanessa. I'm just curious, is there any condition you would see your bees in that you would opt not to do that feeding? Like, could you be convinced by the environment, oh, they don't actually need it, I'm going to take that chance?
Not to date, no. I think that's why these studies are so important, because I would hope that with more studies and more trials and trying those control groups with nothing at all, and taking those environmental conditions, I'm hoping we can get to a point of precision agriculture in beekeeping, to where we can look at the year and the conditions and say, no, it's not necessary this year. But we're not there yet. And so, I mean, I'm not going to be feeding pollen substitute in the spring, when there's an incredible natural flow. But in those critical fall months, as my bees are preparing for winter, yeah, not really, not without more research. And I don't work for any pollen substitute companies, by the way. I pay them a whole lot of money, though.
I have a question for both of you. What is the value of the researcher and beekeeper relationship, where you're working so closely together? What does that mean to you? And Blake, what is that experience like for you, working with a researcher and donating essentially the use of your hives for this effort?
Yeah, I mean, man, Vanessa and her whole team made it incredibly easy. We made it incredibly hard on them, and they made it incredibly easy. And so, I mean, I encourage commercial beekeepers all the time to work with any forms of research for their own benefit, for the benefit of the industry. And in my experience, it's really not that hard. And so, yeah, fantastic experience. And I think that this was born out of conversations in the industry of the need for more practical research, and research that affects the bottom dollar really of our operations. And so, I definitely applaud Vanessa and her team for taking this on, and we need a whole lot more of it. And I think as an industry, we need more of it. So yeah, that definitely very needed, very appreciated.
Well, I think that, we feel the same way in terms of working with Blake and his crew. We had a great experience, and, he says they made it hard, but no, that's not true. I think that he's just got a lot of balls in the air and a lot of things to work with. And we just try to sort of fill in the cracks and adjust as necessary. And it was a pleasure working with him and his team. I think the value for us is, let's just say sometimes we get our blinders on, right? And we get very, focused on these areas or these features of, say, nutrition. And we need to kind of step back and say, and work with folks in the industry to kind of bring us back and help us in a very collaborative way to address the questions that people want to address, people want us to address. And so constantly having these lines of communication open, and also having these collaborative projects that are funded and supported by, Project APISM and Healthy Hives really helps that to always be happening. And so it was a great experience for us.
And I have to say from Pam, we're so happy to fund a project that's a beekeeper's idea, and a researcher has the skills and the will to actually study that question. And for you two to say, well, how about we don't do it in Tucson? How about I give you a truckload of bees to work with in my operation, and that makes the results so much more applicable for the beekeeping industry. So that's what Pam really loves to see. This project itself happened, it came about on a panel at a bee meeting. So it can happen if you have good ideas about research. Pam wants to be that vehicle to make things like this happen. So thank you both.
Thank you.
We are almost at the top of the hour. This has been really great. Thank you to everyone. I have one quick last question to close us out that I know is kind of at the top of everyone's mind, and this came in through an email. But how does this study compare to Randy Oliver's recent study? And what does the future of this sort of research maybe look like?
Right. Thanks for that question. So I have been keeping up with his articles in ABJ, and really sort of comparing the two, my efforts with his. What was really interesting, there are a couple things that were really interesting. He also found that the sort of diet-based differences and the better, let's say, performance of the global 4% patty was, I think, also something that he found. So it was nice to see those two line up. And if he's on the call, I don't want to completely, I don't want to tell, I don't want to put words into his mouth. I definitely would encourage anybody to, read those articles in American Bee Journal, because they're really great. He also saw these site-based differences. Location is important. So that was also something that was encouraging to see. He was also working, or he was not working with hives that went into cold storage, but they were outside the whole time. So I think that was actually kind of interesting too, that they lined up despite those two different sort of trajectories. So they actually do parallel each other very well.
Yeah, that's great. Thank you. We are just about at the hour. Thank you all. We really appreciate your time. Thanks to everyone who's been tuning in to listen. And Grace put a little survey in the chat. If you have, it would take you less than a minute to complete it. It's just a really quick survey asking what you thought. And if there are additional topics you're interested in hearing from Pam about, then we'd love to hear your input in that survey. Yeah, and with that, we will go ahead and close the meeting. This will be up on our YouTube channel at some point in the future, so sign up for our e-news to be notified.
Thank you.
Thank you.